Hello everybody, my name is Ana Cecilia Valdez and today I will be presenting my first laboratory practice on constant velocity. This we want to obtain an empirical understanding of Newton's second law of motion through using video analysis and globe script coding in order to create an observed motion and a predicted motion scenario. And also these two softwares will help us compare and contrast the motion in a predicted scenario and in an actually observed scenario. This will help us relate and understand better velocity, momentum, and net force. Just to recap a little bit on Newton's second law of motion, this law relates the net interaction between systems and surroundings to the observed motion of the system, and it yields the formula that the net force is equal to the change in momentum over the change in time. Well, momentum is just an indication of how hard or easy it is to change the object's motion of an object in movement. For the experiment, our system it consists on a physics collision card that has a mass of 0.5 kilograms, and it is made of aluminum and it has four wheels. It is 17 centimeters long and it follows a track of 200 centimeters. And well, this is a video of our experiment. As you can see, it follows the negative x. The object follows a motion through the negative x-axis, and due to the camera, it moves a little bit downwards towards the y-axis. But that doesn't really matter because we are not really taking into account the position in the y-axis, and well, that would be a point that we might be able to improve in another occasion. And well, the initial position yielded by the tracker analyzer, it's supposed to be negative 0.353 meters, so 0.353 meters to the left, and the initial velocity that was calculated with the help of the data of the tracker plus the velocity formula resulted to be negative 1.3 meters per second. And well, here we can answer the question: what happened if the axes were flipped? In terms of magnitude, nothing will happen because of the way the formula is established. We have to calculate the magnitude squaring values, so that means magnitude will always be positive. The only thing that would change would be the slope. Instead of having a downward slope, we would have an upward slope. We also created a predicted scenario through coding in CloseScript, and we initialized the codes to have a zero point 0.5 kilograms in mass, initial velocity of negative 1.3 meters per second, and an initial position of negative 0.353 meters. And also, we initialized the time here. We calculated the size of each time step, and we place our total time here. And well, velocity is constant. These formulas can show us that a constant velocity equals a net force of zero. The momentum update formula tells us that net velocity is equal to change in momentum over change in time, which at the end can give us that a final momentum is equal to the net force plus times the change in time plus the initial momentum, which then we can derive the velocity update formula from there. As I was saying at the very end, it is easy to figure out that net force must be zero in order for the final velocity and the initial velocity to be the same. And well, the predicted motions result gave us a constant velocity. And here is the comparison between the globe script, the predicted motion, and the actual motion. And we can see that the slope in the predicted motion is perfect, and it is not in the actual motion. It is pretty less steeper at the beginning, and that is probably due to the fact that there is friction, that there is a resistance, and that it is like man-made. So we do not have control. We cannot have a perfect environment. And well, in conclusion, is the net force really zero? In the observed example, it probably isn't, because we have to consider factors, as I just mentioned, that are friction, that are air resistance, and errors just in the experiment. And well, this experiment helped us relate better the concepts that make up Newton's second law of motion, which is uh, momentum, velocity, and net force. And we can see how observed motion and predicted motion are not the same, but still they are similar enough to sustain Newton's second law of motion.